So this one is classified paper or topics 9, which is about the metals. Page number 3, zinc sulfate crystals. Hydrated crystals are there, large pieces of a zinc carbonate added to sulfuric acid until we get a hydrated salt. As you can see, the points of crystallizations are also shown. In step 1, zinc carbonate is in excess when no more zinc carbonate dissolve. State other observation. How we know that zinc carbonate is in excess? Like we have more than enough zinc carbonate in this reaction. One of the observation is no more reaction, like no more dissolve. What else we'll observe? So there will be no bubbles. No more bubbles will be seen. No, start settling is actually it's given already. Solid does not dissolve. Your effervescence stop. No more bubbles that you can mention, but you cannot mention start settling the solid because already this part is already mentioned. There is no more zinc carbonate dissolve. So it is already there. You're not supposed to write the same thing. That's why you have to mention what state one observation. No more bubbles or effervescence you can mention. So no bubbles are there. No bubbles produce fizzing or effervescence you can mention. Then name a different substance other than a zinc carbonate that could be added to produce zinc sulfate. So metal oxide. What like if we use zinc metal, we use zinc oxide, we use zinc hydroxide. Whenever all of them react with sulfuric acid, it will give zinc sulfate. So any of them you can mention. Any one you can mention. Step 1 is repeated using a powdered zinc carbonate instead of large pieces. Give a reason why the rate of a reaction increase and explain your answer in terms of the particles. So what will happen if you use a powder? It will have a large surface area because small particle size will have a large surface area. So large surface area, it increases the rate of a collision. Good. So there will be more collisions will be there. Or it will increase the collision frequency. So just what is observed when the solution is saturated in step 3? What we'll see when step 3 solution is saturated? So saturated solution, no, how will it's this is not dissolving part. Here we are doing a crystallization. Zinc sulfate was separated. How we separate by filtration, but how we know when we are heating it? No, we'll not mention start settling. How we know aqueous zinc sulfate is heated? Like we have a solution and we are supplying the heat energy to this solution. So when we cool down, when the solution cool down, the crystals start to form or the solid appear. That means the solution is saturated, like no more solute can dissolve. If the crystals start to form, then we'll identify that this is a saturated solution. So how the student will know? Suggest what is observed when the solution saturated in step 3. So we'll observe the crystals or the solid or the will form on the walls of the test of the beaker. So whenever a hot solution start to saturate, and how we can test? For example, if there was a question, how we can test that the solution is a saturated solution? So the normal test for that is We take a glass rod and dipped in the solution. If the solid is formed on the glass rod, it means the solution is saturated. Give a formula for the heated dryness in step 3. So the water of crystallization will be lost and we'll have anhydrous zinc sulfate. This question is related to the topic iron, which is extracted in the blast furnace. Name ore the ore of the iron and used in the blast furnace. So that is hematite. Then name a substance that enter the furnace at A. What is hot air? And name what is collected substance that leave the blast furnace at B. Slag, good. So slag will leave, and here we add a hot air. Give 2 reasons why for using a coke in the blast furnace. Why we use coke in the blast furnace, the carbon. Yeah, so as a reducing agent, right, to heat, to increase the temperature, because coke will react with oxygen to give, basically, coke react with oxygen, give carbon dioxide, so that increases temperature. And you can mention as a reducing agent or to produce a reducing agent, carbon monoxide. Both you can mention. Because carbon or and carbon monoxide both are reducing agents. Another ore of iron is iron pyrite. Reduce the formula of a negative ion. What is the formula of the negative ion? Iron is +2 here. This is a formula for iron pyrite. So this 2 is for Fe. So what should be the oxidation number for? So this 1 here is sulfur. So -1. Same question if it was FeS and they ask what is the oxidation number or charge on sulfur. So because if iron is +2, when nothing is written, it means both elements have the same oxidation number value. And positive and negative different, but the number, if the nothing is written, it means same. But if something is there, like say magnesium nitrate, so this 2 is with magnesium and 3 with nitrogen. But if it was like magnesium oxide, so this is +2, they have the same oxidation numbers. Iron is a transition metal. A list of properties are shown. It's a good conductor, soluble salt, colored compound, variable. 2 properties from the list which iron differ from group 1. What are the difference? So catalyst, colored compound, yes, you can mention that also. So all metals are good conductors, so this is a similarity. Iron forms soluble salt, group 1 also forms soluble salt. Colored compound, that is a difference. Variable oxidation number is a different. Act as a catalyst is a different. Form a basic oxide is a similarity. 2 properties which are similar. Tensile strength is not given here. As you can see, the property tensile strength is not given. So you cannot mention that because the question was you have to use a list. Give 2 properties from the list. So tensile strength is not from the list. That's why you're not supposed to write anything outside the list. Conductivity is same. Form basic oxide is same. Form soluble salt is also. Steel consists of mainly iron. Iron forms rust when it reacts. Magnesium block can be attached to a bottom of a seaboard. Magnesium does not cover the steel. Explain how magnesium prevent iron from rusting. So it's the same with the sacrificial protection. What happened? Magnesium is more reactive than iron. Magnesium will lose electron first. Magnesium will oxidize instead of iron or electron transfer from magnesium to iron. Explain why replacing a magnesium with a copper will not prevent the board from rusting. So if we Copper is less reactive than iron. So in this case, iron will be oxidized and rust instead of not more reactive. You should mention copper is not more reactive. Copper is less reactive. Iron is more reactive. So copper is less reactive. As copper is less reactive, so in this case, iron will react and iron will be oxidized instead of copper. So this was page 8, 7 and page 8 answers are there.